the weight of the output. In this way, you can say when I'm calculating the Hamming distance between 0, 0 and 0, 1, where the 0, 1 is output, the Hamming distance is 1, and which is equal to the weight of the 0, 1 or weight of the output, which is also 1. Okay. So it is only possible for the linear code. Okay. When the convolutional code is linear. So almost all the convolutional code is linear. By the way, so the thing is that we have calculated all the Hamming distances, or you can say the path gain. Okay, path gain. This is 2, this is 1, this is 2. So there is several possibilities where I'm coming from SA to SA. The next possibility, so this was my one possibility. There is SA is B, the lead. SA is B is C, and again SA. Another possibility is given SA is B is C is B is C is A. Okay, so this is basically SA is B, like SA is B, is C, again is B. That means this I'm following this path. This is B. Again SC, that means this path is C, and again AC, that means this W structure, you can say. Okay, so this structure, this again this and this W structure. So if I follow this path, you can see that here also we can got the Hamming distance. Okay, like from this path we have got the path gain as 2 plus 1 plus 2, so this is 5. So from this W structure, if we follow this path, so this was 2 plus 1 plus 0 plus head is 1. This is also 2. So 2 plus 1 is 3. Again 3 plus 3 equals to 6. And for this also there is SA, SB, ST, SC. So in this way we can see that this path, okay, this path, if we follow this path, the path gain is minimum, which is 5. So that's why DF equals to 5, or you can say the D free equals to 5, or free distance equals to 5, or you can say the minimum free distance. This minimum free distance or minimum Hamming distance of the convolutional code is 5. So this is the way you can calculate the minimum Hamming distance from the code tree. So first of all, the thing is that you have to consider the CCON 2 and 2. So you have to make the table. So let me erase it. Okay, so you have to make this table, and then you have to make the code release. Okay, like you have to make you have to make the code release like this, or you can say like this. This was your code release. Okay, so then the thing is that you have to consider that you have to start from all zero state, like this is all zero state, and again you have to come back to all zero state. Okay, to determine the minimum Hamming distance, and then you will see that you have to take at this position all 0, 0, 0. That means all zero states. Okay, you have to divide the segments. This is one segment. This is one segment, like Bartabi algorithm. Okay, so like Bartabi algorithm. So in the Bartabi algorithm, we have considered the received code sequences in these places. Okay, so here we will consider all 0 states. Okay? So this will be all 0 state. Then you have to write all the corresponding outputs from the table you have already made. Then you have to calculate the Hamming distances, and that Hamming distances will be equal to the weight of that output. Why? Because I'm calculating the Hamming distance with respect to all 0 port, as I've told you before in the theory part. So you will get the all Hamming distances, and then you have to add the all Hamming distances, and you have to find that what path gain, that means what path containing the minimum path gain by adding all the Hamming distances. Okay, so then what we will find, that will be your minimum free distance or minimum Hamming distance of the convolutional code, and which is 5. You can say that this is 5 by the trellis method. You have already calculated the minimum Hamming distance 5 from the state diagram procedure. So you can see, so I'm just repeating again, I'm just telling you that you have to follow this code trellis diagram from this book. The page number is 180, and you can see that this is the block of 6.10, the minimum free distance of the convolution. This is a code trellis diagram. You can also follow that this is the distance properties of the convolutional code, which I have already told you, and this is the book. So this is the procedure. So you can, what I was telling you, that from both method, state diagram and the code trellis diagram. So from the both method, the minimum Hamming distance is basically 5. So I hope you will understand. You can understand the procedure, how I'm calculating the minimum Hamming distance from the code trellis, and also minimum Hamming distance from the state diagram, or you can say the modified state diagram, right? Okay, thank you. And the next thing, the next video will be on short video. It will be on the short video. It is very important question from your examination, previous examination, that what is the Hamming distance, and what is the relation between the error control or error correcting, actually the error correcting capability, and the minimum Hamming distance. So the question is asked several times in your examination, McCourt examination. So this is very important, that what is Hamming distance and what is the relation between minimum Hamming distance and the error correcting capability or error correction capability. Okay, so we will discuss it in the in the later video. So thank you.